Well, welcome back. We've got a great little topic for us tonight called systems of equations. Now, we might have done a few of these throughout the year, so hopefully you'll feel pretty confident with it. So the first thing we want you to highlight in your notebook here is we can solve systems of equations two ways, algebraically versus graphically. All right, so let's go ahead and make this T-chart in there, and you can just sketch this the best you can, and we'll start with the algebraic side. All right, so here's our recipe, and you want to make sure you have these listed out, and this is how we're going to solve these step by step. So number one, solve one equation for one variable. And I just want to make a note that it can be x or y. It doesn't matter. A lot of people always think they have to do y first, but it really doesn't matter. Two, substitute that equation into the other equation. All right, so we can just highlight this word substitution. Okay, that's what we are doing. We are substituting one into the other. Three, solve for all values of x. Pretty straightforward. Four, substitute each x value into the equation to get a y value. And five, our final step here is write your solution as a point. So I just want to be clear, every time you solve one of these, I should have a comma b, okay, a number comma something. Everybody should be a point. Now, it might make a little more sense graphically, so let's compare this. And again, you can just sketch your own two lines here. All right, so if you solve graphically, what we're really doing is we're looking for these 2 points, or these two lines, I should say, or functions, to intersect. All right, and that's why we're stating our answer as a point when we did it algebraically, because when lines intersect, or when a parabola and a line intersect, or a circle and a line intersect, they intersect at what we call a point. So let's go ahead and tackle problem one together. So we have y equals x squared minus 6x plus 6, and y minus x equals negative 4. All right, so I'm going to solve one equation for one variable and substitute it into the other. Now watch this. This equation, would you agree, is already solved for y? So I don't actually have to do anything. It already says y equals. I'm basically going to take this piece and substitute it into the other equation. Okay, so in place of this y here, I'm substituting that other equation, x squared minus 6x plus 6. Okay, all of that right here just took the spot of y. Now you still have the minus x and the equals negative 4. But that was it. Our first step was done for us. One equation was solved in one variable, and we just substituted it into the other. Now we'll just simply solve this equation. Of course, we want one side to equal 0, so I'm going to add 4 to both sides and combine my like terms. X squared, this minus 6x and minus x make minus 7x. 6 plus 4 gives me a plus 10 equals 0. I'm going to go ahead and factor, of course. All right, so remember it's multiply, add, multiply. What multiplies to x squared would be x times x. What multiplies to 10, well, I can say, okay, I can use 1 and 10, I can use 2 and 5, but those two numbers have to combine to a 7. 1 and 10, if I add them, makes 11. If I subtract them, makes 9, so that's out. So I know I've got to go with 2 and 5. This also tells me, because it's positive, the only way to multiply to a positive, the signs have to be the same, and this one's telling me they're both negative. We'll tee it up. Set each piece equal to 0, and I get x equals 2 and x equals 5. Now, most importantly, I need you to remember, you are not done there. Remember, everything intersects at a point. So I need to go back and substitute each x value in to get a y value. Now, here's the key, guys. It doesn't matter which equation you use. If you want to use the first one, go for it. If you want to use the second one, go for it. It doesn't matter. I'm going to use the first one because it says y equals, but again, it doesn't matter. Y equals x squared minus 6x plus 6. Okay, so the first thing I'm going to do is substitute the 2 in. So y equals, let's see, 2 squared minus 6 times 2 plus 6. 2 squared is 4 minus 12 plus 6. I believe that gets me a negative 2. So this answer is 2 comma negative 2. And then I'm going to do the same thing with the 5. Y equals x squared minus 6x plus 6. And I'll substitute that 5 in. So 5 squared minus 6 times 5 plus 6. Let's see, that's 25 minus 30 plus 6. 25 minus 30 is negative 5 plus 6 is 1. So I would say this point is 5, 1. So I just want to be clear, these are my two solutions. Now you might be thinking that was too easy, and you're probably right, it was pretty straightforward. Let's try a little more complicated one. We have x squared plus y squared equals 52, and x minus y equals negative 2. Now look, I am never going to solve this equation for y. If I do, I'm going to end up with a square root in it, and nobody wants to deal with that, all right? So this would be the wrong one to solve for y. This equation is much simpler. Okay, so this is the one I want to solve for x or y. Now just to prove to you it doesn't matter, I'm going to solve for x. I'm going to say x equals negative 2 plus y. Okay, and again, it didn't matter. I'm going to move this y over, and I get negative 2 plus y. So I'm going to take this equation and substitute it into the x in this equation. So let's see, I've got negative 2 plus y, use parentheses when you substitute, and now watch, you have to square that, plus y squared equals 52. Okay, now how do you square something? All right, hopefully that F word of FOIL just popped in your head. So I'm going to say it's negative 2 plus y times negative 2 plus y. And I'm going to FOIL that out. So let's see, that's going to get me 4. Maybe you can go ahead and get your answer here. Oh boy. Minus 2y would be minus 4y plus y squared. Then I'm going to keep this plus y squared equals 52. All right, so remember I want to set it equal to 0 and put any like terms I have. So I'm going to subtract my 52 over. This y squared and y squared gets me a 2y squared minus 4y. And 4 minus 52 gets me a negative 48 equals 0. All right, now let's talk about some smart factoring. Hopefully you're not jumping into multiply, add, multiply right away. Do you see a GCF? That would make our life a lot easier. All of these numbers are divisible by 2. So I'm going to pull the 2 out, don't let it disappear. And I've got y squared minus 2y minus 24 equals 0. Okay, pull that 2 out. All right, so now I'm going to leave the 2 in front. It cannot disappear. And now I can say multiply, add, multiply. All right, y times y is y squared. So again, I've got my 1 and 24, my 2 and my 6, my 3 and my 8. I got to get a 2 out of that. Whoops, I meant 4 and 6. 2 and 12. So let's see, obviously I'm going with 4 and 6. This negative tells me the signs have to be different, so 4 and 6. And if I want a negative 2, the 6 has to be negative, the 4 has to be positive. All right, now watch when I tee it up. I'm going to actually tee it up in 3 different places. And take the time to write these down. 2 equals 0. Y plus 4 equals 0. Y minus 6 equals 0. Can you solve all of them? All right, well, this one I can. I get y equals 6. This one I can. I get y equals negative 4. Does this one make any sense? Does 2 equal 0? Is there even a variable? So I want to make a note. No variable means no solution there. Okay, that one gets rejected. There's no variable, so there's no solution. All right, now just remember, you're only halfway done. Right now you have the y values. You need to go back and get the x values. So remember, it doesn't matter what equation you pick. I'm going to pick this one because, again, it's simpler. All right, this one is much nicer. And in fact, I'm going to use the cleaned up version of it, the x equals negative 2 plus y. So x equals negative 2 plus y. And I'm going to plug my negative 4 in. So x equals negative 2 minus 4, which is negative 6. So this point is actually negative 6, negative 4. And I'll do the same thing with the positive 6. X equals negative 2 plus 6. So x equals positive 4. So this point should be 4 comma 6. Make sure the x comes first, the y comes second. Just don't fall for that. And there you have it. You have 2 solutions. There is that one and that one right there. Now, I do want to solve this one graphically as well. All right, and this will be a great review for us. So let's go ahead and talk graphically. Now, that just means we're going to graph it, but you have to realize who you're staring at. What function do we know, well, actually not a function, that has an x squared and a y squared? What does that look like? What shape are you thinking? Hopefully you're thinking x squared and y squared remind you of a circle. Okay, and this circle has nothing added to it, so it's centered at the origin. And the radius, remember r squared is what it's equal to because everybody's squared, x squared plus y squared, this is actually r squared. So r squared equals 52, so r is equal to the square root of 52. All right, so that's a circle, and this is just a boring old line here. I can solve for y, so x minus y equals negative 2. I'm going to say negative y equals negative 2 minus x, and then I have to divide that negative out, and I get 2 plus x. So I'm basically graphing a line and a circle and seeing where they intersect. Let's make a rough estimate of that. All right, so we know our circle is centered at the origin, so I'm going to put my center here. And my radius is radical 52. Now radical 52, of course, isn't a nice number that we know, so I'm going to cheat in my calculator and say that's about 7.2. So I'm going to go out 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7 in every direction. Well, up, down, left, and right. And I'm going to go about 7.2 and draw those and connect and make a nice circle. And just kind of get the best circle that's obviously not a very nice looking circle, but just kind of do the best you can for the time being. And then let's go ahead and graph this line. Y equals 2 plus x. Let's get a little review in here. The solo number is the y-intercept, so that's going to be at 2. And the number in front of x is my slope, which is a 1, which means I rise 1, run 1, rise 1, run 1. So it should look like this. And you can clearly see that you have 2 points of intersection, and we now know exactly what they are. Those are the 2 points that we found above here. Okay, 4, 6, and negative 6, 4. Negative 6, negative 4. And again, those are our 2 points solved graphically and algebraically. All right, question 3 out of 4 here. So again, I want you to take note that we have a circle right here, and we have a line. And again, it's a circle because there's 2 terms squared. We're going to solve it algebraically. Now, again, it may not look as nice to you, but I don't want to solve anything with a squared. So this is the one I want to solve for either x or y. Now, if a variable was by itself, that would be the one I'd solve for. In this case, I don't have an option. So I'm going to say 3x, I'm going to add that 4y over, is equal to 4y. And then I'm going to solve for y, I guess, so I'm going to divide each of them by 4. So it's not very pretty. 3x over 4 is what I get for y. This is what I have to substitute into this y value. So we're just going to be very careful on this one. And this was an old Regents question. Okay, so when I substitute this in, I get 3x over 4 squared equals 25. Okay. Now, we're all good at squaring things. Remember, when you have a fraction, you just do it to the top and the bottom. No big deal. The 3 turns into a 9. The x becomes x squared. And the 4 turns into a 16 equals 25. Okay. Now, this is called a fractional equation. We actually did solve these a while back. Basically, when you have one of these, you just want to ask yourself, what is the common denominator? Now, you can put all of these over 1 if that helps. So the common denominator is pretty obvious. It's 16. So I'm going to multiply each term by 16. Okay, however many terms, that's how many times we're going to do this. All right, now nothing's going to cancel in this first one, so I literally get 16 times x squared. Plus, now here's the beauty, guys. The whole point of multiplying by 16 was it canceled those. So all I'm left with is 9x squared equals 25 times 16 gets me 400. All right, and I've eliminated the fraction, and that was our goal. So now I've got some like terms. 16 plus 9 gets me 25x squared equals 400. Divide by 25. And I get x squared equals 16. Now don't fall for this bear trap, guys. There's more than one answer here. Every time you slap your own square root on, don't forget that plus minus. So you actually get x equals 4 and x equals negative 4. Now, halfway done, we just need to go get those y values. So let's scroll back. Let's see, and I'm going to use this cleaned up equation. Remember, you can use any one of these you want. Here's my nice version. I'm going to use y equals 3x over 4. So y equals 3x over 4. If I plug the 4 in, I get y equals 12 over 4, so y equals 3. So 1 point would be 4, 3. And if I plug the negative 4 in, I get y equals negative 12 over 4, so y equals negative 3. So negative 4, negative 3. So again, I've got 2 solutions. All right, well, we've done it. We've made it to the last problem for the night. And again, I really just want to stress that it doesn't matter if you solve for x or y. Now again, looking at the two equations, which one's nicer? The first one or the second one? Hopefully by now you're saying this first one. We don't want to solve for anything with squareds in them. Get that out of your head. Now here's where I want you to be a smart thinker. Which variable is easier to get alone? The x or the y? And again, maybe make a little note to yourself, okay? The variable that's alone is the easier one. That's the one I want to get alone. This y has a 2 in front of it, but this x has nobody. This one's the winner because it's easier to get alone. So 2y plus x equals 5. Therefore, x equals 5 minus 2y. And I just want to show you, watch what would have happened if I tried to solve for y. Watch how ugly this is. I would have to subtract the x over. And then I have to divide everybody by 2. Does anybody want to plug in 5 halves minus x over 2? I mean, that's just hideous. I would never want to do that. So pick the easier variable, and that's the variable that's alone. All right, well, you've got the drill by now. Why don't you pause it, see what you get, turn it back on, and see if we agree. Good luck. Was your first step right? I substituted that into the x, and now I have to slow down and square it. So I'm going to pause it again, see if it matches. Check out my second step. I FOILed. All right, and now I'm just going to combine those like terms together. So I got a total of 5y squared minus 20y, and I'm going to have to subtract that 10 over, so I'm going to get a plus 15 equals 0. Now again, I'm not going to try to factor that if I have a GCF, and I think I do. They're all divisible by 5, so pull that 5 out. I got my minus 4x plus 3, and now we can nicely factor, bring that 5 down along for the ride, multiply, add, multiply, y times y, 3 times 1, positive means the signs are the same, that tells me they're both negative, and then I'll tee it up. Okay, 3 little t's there, y minus 1 equals 0, y minus 3 equals 0, and 5 equals 0. Again, no variable, no solution there. Hopefully we got y equals 3 and y equals 1. And then lastly, we just got to go and make sure we get that point just like we've done on every one. I'm going to say it's x equals the 5 minus 2y. X equals 5 minus 2y. If I plug the 3 in, I get, let's see, 5 minus 6. I get a negative 1. So I would say that that solution is 3 negative 1. And let's see, here if I plug the 1 in, x equals 5 minus 2y. X equals 3. And I'm going to say that solution. Oh boy, did you catch my mistake here? Hopefully you did. I apologize for that. I got to put that x value first. Oh boy. So this is negative 1 comma 3, and this one should be 3 comma 1. All right, so even I fall for that once in a while, so let's just be careful. Make sure the x comes first, then the y. Well, that does it for us tonight. We look forward to seeing you tomorrow. Have a great night.